This is Math Studies, Lesson 9.1, Arithmetic Sequences. An arithmetic sequence is a list of numbers with a common difference. And what that means is we're basically adding or subtracting the same number over and over and over again to generate a list of numbers. So the easiest arithmetic sequence would just be 1, 2, 3, 4, 5. All we're doing is adding 1 to get the next number, adding 1 to get the next number, adding 1 to get the next number. Or 2, 4, 6, 8, 10, 12, adding 2. 3, 6, 9, 12, 15, 18, adding 3. Or, even adding a negative number like 100, 99, 98, 97, adding negative 1. The common difference is the name we give to the rate of change, what it's adding or subtracting every time. And we can calculate a common difference by taking the second number in a list of numbers and subtracting the first number in that list of numbers. Oops. Second number. So in the sequence 1, 2, 3, 4, 5, it's pretty obvious that we're just adding 1, adding 1, adding 1. But if we weren't sure, we could take 2 minus 1, the second number minus the first number, and figure out what it's changing by. And that's helpful when we have more complicated sequences, especially sequences working with decimal points or negative numbers. A recursive formula is a way to represent getting the next and getting the next and getting the next. And we do that with two things. With the first number, or any given number, and then a representation of adding or subtracting whatever value we need to change. An explicit formula is a way to jump directly to a specific answer without having to get the next answer and the next answer and the next answer and the next answer. The general explicit formula that I'm going to use is u sub 0 plus d times n. So that means the 0 number plus the difference. If we don't know the 0 number, there is a way to figure that out. That would be taking the first number and subtracting the difference. And I did write this up top, but I'm going to write it again. If we subtract the first number from the second number, it gives us the difference. Now I think we're going to go on to the examples. I'm going to leave those up there. Example A is giving me an equation in recursive form. So it's telling me the 0 number instead of the first number, like the example I wrote up top. But it's also telling me the rate of change, the common difference. So it's saying that we're going to start at 18, and we're going to change by subtracting 3, subtracting 3, subtracting 3. And I want to use that information to get the first 4 terms of the sequence. So I'm going to go to my calculator. I don't know if we necessarily need one, but I want to show you how I use the calculator to do this so that when you have more complicated versions, you can see how to use it. When I have this set up, I'm going to seed it. So I'm going to put in my starting value, and then I'm going to hit enter. And it's kind of weird to not type any operations after that, but this is the process that's going to allow me to use the calculator recursively. So when I hit plus, this answer thing pops up by itself, and that's what I want you to think of this un minus 1 as being. This is the answer. So we're not actually going to do any subtracting of 1. That subscript is the same thing as answer on the calculator screen. So we have 18 for our top row, and then underneath that we have answer plus negative 3. And we can write minus 3 or plus negative 3. That has the same effect. But just to represent this the exact way the formula is written out, when it's seated this way, I can go 1, 2, 3, 4, and every time I hit enter, I'm getting the next answer, and the next answer, and the next answer, and the next answer. So I'm going to represent this as u sub 1 equals 15. That was the first answer I got. When I added another negative 3, my second answer was 12. When I added another negative 3, my third answer was 9. And I added another negative 3. My fourth answer was 6. write an explicit formula. So now I'm going to try to write one like this. To do that, we're going to substitute values in for UN and D. And those values are given right here, our U0 and our D. So the 0 number in this case is 18 plus -3 times n. And I don't have to do plus -3. I can just do -3, but I'm going to represent it the same way as the formula up top. Now, to show you, before I go on to example B, the benefit of an explicit formula is if I wanted the fourth answer without having to get answer 1, answer 2, answer 3, answer 4, I can substitute whatever value I need to into the parentheses to jump directly to the fourth answer rather than have to go enter 1, enter 2, enter 3, enter 4. So recursive formula is nice when you want a list of values. Explicit formula is nice when you want to jump right to a certain answer. Example B, consider the explicit formula u sub n equals 15 plus 7n. Use it to find the first 4 terms of the sequence. So I know that this is my 0 number, and I know that this is what it is changing by. So I'm like 15 plus 7, plus 7, plus 7, plus 7. Now I can do this explicitly, and that's 15 plus 7 times 1, and get my first answer. And then 15 plus 7 times 2, and get my second answer. And then 15 plus 7 times 3, and so on. Except I messed that one up, but you get the idea. That takes longer to generate a list of numbers than it would to go the recursive way, whereas if we put in our starting value and then write plus 7, we'll have answer 1, answer 2, answer 3, answer 4. So you can do it the explicit way, plug in 1, plug in 2, plug in 3, plug in 4. Or the recursive way, plus 7, plus 7, plus 7, plus 7. Either option is giving you the first answer and the second answer and the third answer and the fourth answer. And I kind of did this on my own, but the 0 number is right here, 15. And then when I went into the calculator, I put answer, remember this is answer, plus 7. Example C, consider the sequence -12, -3, 6, 15, and so on. We want to write a recursive formula, then write an explicit formula, then find the 18th term. So I need 2 things for a recursive formula. I need where it starts, and I need how it changes. So we're going to fill in how it starts and how it changes. I am going to look at how it changes first. So how do we get from each number to the next number? To calculate the common difference, if it's not super obvious, we can take the second number minus the first number. If we subtract going this way, it'll tell us how to add going that way. So -3 minus -12 is 9. So I know that this is plus 9, and I'm going to check that's for sure plus 9 here, that's for sure plus 9 here. I like plus 9 as my common difference. So now that I know the common difference is 9, I want to go backwards to figure out what would the number in front of the -12 be in this pattern. That's my 0 number, right? First number, second number, third number, going backwards, third, second, first, and 0 number. So I know that it's plus 9 to move forward, plus 9, plus 9. So if I want to go backwards, we're going to minus 9, and then we're going to minus 9. So if I have -12 minus 9, that's going to be -21. So now that I have my 0 number and my common difference, I can write my explicit version. U sub n equals, I need my 0 number, plus I need my common difference, and then we're going to stick an n in there so that we can substitute different values in to jump to specific answers. Like in the very next example where I want the 18th answer, I'm going to substitute 18 in for n. So that'll be -21 plus 9 times 18. And I can jump here with negative 21 plus 9 times 18. I know that that is 141. Now, I always also had the option of doing this recursively, but I feel like if we're jumping to a certain answer, it's much faster to do it explicit, whereas if I wanted a list of numbers, then this version becomes a little bit faster. So let me count as I'm going. That's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Hopefully I didn't lose count. 141 matches what I got explicitly, and that is it. That's it for the notes. Good luck on the exercises, and please let me know if you have any questions.